Yes, good day. This is 300 plus academy where our work is well cut out because all we do is exams, tutoring, making sure you ace your next exams. I am Adeyemi Abiodun, the lead tutor at 300 plus academy. So, very quickly, let's get into the subject. Of the day. It is mathematics, and the topic is exponential equation. I haven't looked at indices in the last lecture, so very quickly, we have some set of questions. But first, when we say exponential equation, recall that if we say 2 raised to the power 5, 5 is our exponent. 5 is our exponent. In the case of exponential equation, we will be dealing with the exponent or the power or the index. And in this situation, let's say I have 2 raised to the power x. X here is the exponent, fine, is the exponent. And in this case, it is the variable. It is the variable which we are to look for. By the way, in most cases, this is what we are to look for. Usually, the letters that we are to look for the variable term now is the exponent. The reason why we call it exponential equation, and in this case, there must be an equality sign. So this is not an indices expression, but rather this is an equation. But in this equation, our unknown or variable is the exponent, and which in the case of exponential equation is what we are going to be solving for. So moving on very quickly, I will look at question 1. Most of the questions here are JAMB or UTME questions. You look at the very first one, it states 0.25 all raised to the power 2x plus 1. 0.25 all raised to the power 2x plus 1 equals to 64. You can see I have my equality sign in there, and then talking about my exponent, it is a variable term and which I am to look for. So I'm looking for x. I want to solve for x. In the first instance, this is a decimal. So the first thing you do is to convert your decimal into fraction. If you have 0.25, it simply means you move the point to the front of the last number. So this is 1, 2. I'm moving the point here, so that means 25. When you move your point twice, that is going to mean your denominator becomes 100. So this is 25 over 100 all raised to the power 2x plus 1 equals to 64. And then there is the idea that we talk about under exponential equation. It is called lowest common base. Lowest common base. But let's move on. I'm going to talk more on this much later. Now, 25 here is 1, 25 here is 4. So what I have here is 1 over 4 all raised to the power 2x plus 1 equals to 64. But then, for me to have 1 over 4, that must have been 4 raised to the power minus 1. Recall that in the case of indices, we said x raised to the power minus 1 equals 1 over x. That's negative index because the negative power or the index here becomes 1 over x. So in this case, this becomes 1 over 4 means 4 raised to the power minus 1 all raised to the power 2x plus 1 equals to 64. So in this situation, how do I make what is on this side, the base particularly, what is the base I have on the left hand side to be equal with the base I'm going to be forming on the right hand side? In this situation now, what I can do is to say, okay, this is 4 raised to the power minus 1. Of course, product power, okay, I can leave this for now. 4 raised to the power minus 1, all close bracket, 2x. So my 64 is going to mean 4 raised to the power 3 because 4 times 4 times 4, that's 64. So 4 raised to the power minus 1, 4 raised to the power minus 1, all raised to the power 2x plus 1. Now, the issue here is that this 4 can take out this 4 because the base now looks the same. So minus 1 times 2x minus 2x minus 1 times plus 1, that is minus 1, equals to 3. So minus 2x equals to 3 plus 1 when minus 1 moves to the right hand side of the equation, and I'm going to have minus 2x equals to 4. Therefore x equals to minus 4 over 2. Therefore x equals to minus 2. That is my answer. Moving on to question 2, we have 10 raised to power minus x equals to 0.00001. Okay, the first thing we have to do is to convert this decimal to fraction. 0.00001, by the way, that's 1, 2, 3, 4, 5. We move it to the front of the last number, so that is 1 divided. We've moved it 1, 2, 3, 4, 5. 5 times, that is 100,000, as that has 5 zeros. So this means 10 raised to power minus x equals to 1 divided by 100,000. Okay. Now, being 10 raised to power minus x, 10 raised to power minus x, I could split this down into 10 times 10 times 10 times 10 times 10. Yes, 10 multiplying recurrently 5 times is what will give us 100,000. 10 times 10, 100. 100 times 10, 1,000. 1,000 times 10, 10,000. 10,000 times 10, 100,000. So that this means 1, 2, 3, 4, 5. So 10 raised to power minus x equals to 1 divided by 10 raised to power 5. Of course, based on negative index, I said if we have x raised to power minus 2, this negative index is going to mean 1 over x squared. So in this case, for me to have 1 divided by 10 raised to power 5, that's going to mean 10 raised to power minus 5 equals to 10 raised to power minus x. Now the base looks the same, this out. Minus x equals to minus 5, minus then takes away minus x equals to 5. That's moving on to question 3 under exponential equation. Now this is what we have: 3 raised to power 2x plus 1 minus 18 into bracket 3 raised to power x minus 81. Of course, because I am seeing 3 raised to power x here, and I got my eyes here on 3 raised to power 2x plus 1. So this is the way I'm going to look at things. This means 3 raised to power 2x. For me to have a plus 1 here, that means 3 raised to power 1. So 3 raised to power 2x times 3 raised to power 1 must have given us this, minus 18 raised to power 3x minus 81 equals to 0. Okay, now what I'm thinking is I could bring out 3 raised to power x here, so that between this term and this term, 3 raised to power x is common. So what that means is that if I say 3 raised to power 2x, it is the same thing as saying 3 raised to power x all squared. Based on product power law, the power of the exponents invariably will still multiply each other. So I still have 2x. So what I have here is simply 3 raised to power x all raised to power square. 3 raised to power 1 is 3 minus 18 into bracket 3 raised to power x minus 81 equals to 0. So that what this means, I can say let 3 raised to power x equals to a. So that where I am having 3 raised to power x, that becomes a square times 3 here, mind you, minus 18. This is a minus 81 equals to 0. So a squared times 3, that will give me 3a squared minus 18a minus 81 equals to 0. This is looking like a quadratic equation, but in a quadratic equation, if you look at all the terms, the first term, the second term, the third term, it looks as though they have a common factor. 3 can go here, that will give 3 in 3a squared will give me a squared. 3 in 18a will give me 6a. 3 in 81 will give me 27. So that way I've been able to simplify the quadratic equation further by dividing through by 3. Okay, so that this is my quadratic equation. I can then solve for a. a square times 27 first time times last time, that's going to give me minus 27a square. What will be the factors? When we say the factors of the quadratic equation, you're looking for two numbers or two terms that if we multiply, we're going to get this, and if we add, we are going to get the middle term, which is minus 6a. In this case, 9 and 3, but I think we can go for minus 9a and plus 6a, because minus 9 plus 6 will give me minus 6a. Minus times, oh sorry, that's a mistake there. Minus 9 and plus 3. The factors here are minus 9a and plus 3. Minus 9a times plus 3 will give me minus 27a squared. Minus 9 plus 3 will give me minus 6a. So that I can then use this to replace the middle term, so that what I have is a squared minus 9a plus 3a minus 27 equals to 0, so that I can then group this. What is common between this and this? That is a minus 9 plus what is common between this and this? 3, a minus 9 equals to 0. So that way a plus 3 equals to 0, or a minus 9 equals to 0. The implication of which is a equals to, this moves here, minus 3, or a equals to minus 9 moves here, plus 9. Okay, in case of these two, I can actually use my 9, because if I'm using my minus 3, that's going to give me mathematical error. So I'm going to go back to where I have let 3 raised to power x equals to a, so that what I have is that since 3x equals to a, then since 3x equals to a, then what that means is that 3x equals to 9, and that will mean 3 raised to power x equals to 3 raised to power 2, and that will mean 3 cancel 3, x equals to 2. That is the answer. On to question 4. One of the things when dealing with exponential equations, we must know also when to form a quadratic equation. We must be wary of that, most especially when you begin to see a constant, when you begin to see a number joined to another number by a product, and you begin to see figures like this. You should know that very likely you're to form a quadratic equation before you proceed with solving things. Like in this case, this means 26. For me to have 5 raised to power x minus 1, that must have been 5 raised to power x divided by 5 raised to power 1, according to division law, and then I have 5 raised to power 2x plus 1. Okay, moving on from that, if I then look at this could mean 26. 5 raised to power x over 5 equals to, I could make this 5 raised to power x all squared equals to, sorry, plus 1. And therefore, knowing fully well that I have 5 raised to power x, close brackets, raised to power of 2, I could say let my 5 raised to power x equals to, let's say, k. Let 5 raised to power x equals to k, so that what I have is 26k over 5 equals to k squared plus 1. Of course, this is looking quadratic in that I am seeing to a degree of 2. Therefore, I could arrange this so that what this means is k squared. Okay, this is going to have to move to the side, so that what I have is minus 26. This is moving to the side. Minus 26 over 5k plus 1 equals to 0. Of course, since the middle term is having a denominator of 5, I could multiply through by 5. So 5 times k squared will give me 5k squared. 26 over 5. 26 over 5k times 5. 5 would have taken out 5, so that is 26k. 5 times 1 would have given me 5 equals to 0. So this is my quadratic equation. First term times last term, that's going to give me 25k squared. What would be my factors if I'm to solve this quadratically? My factors here is going to be, I need a minus 26. I need a minus 26. So if I say minus 25k and minus k, of course, to say minus k is to say minus 1k. Minus 25k plus another minus k. That's going to give you minus 26k. Minus 25 minus 1 is minus 26. But minus times minus is plus. 25k times k is 25k squared. So what I have here, I'm going to use this to replace the middle term. I'm going to use this and this to replace the middle term. So what I have is 5k squared minus 25k minus k plus 5 equals to 0. So that if I then group this, 5k squared minus 25k minus k plus 5 equals to 0, so that this is what I have. So you're looking at this 5k squared. What is common to this and this? That is 5k. Remaining k, of course, 5k, that's going to be minus 5. What is common to k and 5 here? That's just 1, k minus 5, because minus 1 times k will give me minus k. Minus 1 times minus 5, minus times minus plus, 1 times 5, 5 equals to 0. So what I have here is 5k minus 1 equals to 0, or k minus 5 equals to 0. Of course, what this means is 5k equals to 1, so that k equals to 1 over 5. And for this, k equals to 0 plus 5 equals to 1 over 5. It's my k equals to 1 over 5. What am I going to get? I had already said let 5 raised to power x equals to k. So 5 raised to power x equals to 5 raised to power minus 1, because 1 over 5 is minus 1. This of x equals to minus 1. That is the first try there. 0 plus 5 here means k equals to 5. So, or when k equals to 5. So we already know that k is 5 raised to power x. So 5 raised to power x equals to 5 raised to power 1. This of x equals to 1. So in this case, we were told to solve for x. So x equals to minus 1 or 1. That is the answer there. So moving on to question 5, question 3 and 4 gave us a quadratic equation which we had to deal with. But for question 5, we were told to solve for x here. This looks pretty direct. You must think about what we say, lowest common base. In this case of lowest, you look at 9. 9 could be 3 squared. So 3 will rhyme with this. 27 is 3 raised to power 3. That 3 just rhymes. So in this case, this means 3 squared. Then you have 2x plus 1 on the outside times 3 raised to power x plus 1 equals to 3 raised to power 3 or raised to power 2x minus 2. So what we have here is I have a 3 here, I have a 3 here, according to multiplication law. So this normally should be 3 product power law, 2 to multiply this. So 2 times 2x, 4x, 2 times 1, 2, times 3x plus 1 equals to, this here means 3 times 2x, 6x, 3 times minus 2, minus 6. Of course, addition law, multiplication law, so this should be 3, 4x plus 2 plus x plus 1 equals to 3 raised to power 6x minus 6. 3 out. So what I have is 4x plus 2 plus x plus 1 equals to 6x minus 6. So I only need to collect like terms. 4x plus x, 6 comes in, becomes minus 6x equals, I'm left with minus 6 on this side, plus 2 moves to the other side, that becomes minus 2, plus 1 moves to the other side, that becomes minus 1. 4x plus x, 5x minus 6x minus x equals to minus 6 minus 2 minus 1 minus 9. So therefore, minus take out minus x equals to 9. So solving for my x here in this exponential equation is going to give me 9. Okay, question 6. This is what we have. We were told to solve for x, and this is 1978 question 38. So you cannot wish away. Having questions like indices, having questions like exponential equation when it comes to your UTME. So in this situation, I have to think about the idea of lowest common base. I have 25 here, that's going to be 5 square all raised to power x plus 1 equals to 64. 64 is 2 raised to power 6. And what I have here is 5. This 6 is to be distributed for 5 and 2. 5 raised to power 6 and then 2 raised to power 6. Of course, 2 raised to power 6 is going to strike out 2 raised to power 6. So that what I have is 5. 2 times x, 2x, 2 times 1, 2 equals to 5 raised to power 6. The base is the same. The base strikes out the base. So I have 2x plus 2 equals to 6. So that 2x equals to 6 minus 2. And therefore 2x equals to 4. And then x equals to 4 divided by 2. And therefore x equals to 2. That is pretty direct. It is UTME. The reason why I had to increase the pace or the tempo is that UTME deals with precision and speed. Those are the things that guarantee a good score. So you need to work with pace and then precision as well. So just take a look at it very well. What you're dealing with, you always need to apply lowest common base, looking for a way to bring down the seemingly complex number and looking for what can strike out what. Moving on to the next question, what we have here, pretty direct. We have 4 raised to power x and equals 2 raised to power 1 over 2 times 8. Of course, I just begin to think lowest common base. So this means 2 raised to power 2x. 4 is 2 raised to power 2 equals to 2 raised to power half times 2 raised to power 3. Of course, I want to take this and this together. 2 raised to power half plus 3. So 1 over 2 plus 3 naturally should give me 3.5, and that is 7 over 2. That is what this should give me. So 2 raised to power 2x. So 2 raised to power 2x equals to 2 raised to power 7 over 2. Now the base are the same. This takes out this. So you have 2x equals to 7 over 2. And then 2, of course, is going to move to the side. That's 2 times 2x equals to 7. That is 4x equals to 7. Therefore, x equals to 7 over 4. That is the solution to x. If 9 raised to power 2x, 9 plus 1 equals 81, x minus 2, 3 raised to power x, think lowest common base. So here I begin to think 3, 2, 2x plus 1, okay, equals to 3. This is 3 raised to power 4, x minus 2 on the outside, and then I have 3 raised to power x here. So that this means 3. 2 times 2x, 4x. 2 times 1, 2. Equals to 3. 4 times x, 4x. 4 times minus 2 minus 8. Divided by 3 raised to power x. So 3 raised to power 4x plus 2 equals to 3 raised to power 4x minus 8. Of course, divided is minus. According to the law of indices, when you have division, it becomes minus. So this strikes out this. So I have 4x plus 2 equals to 4x minus 8 minus x. So 4x on this side, 4x on this side, out. So what I have is let minus x come here, that's x, equals to minus 8. Let plus 2 move there, that's minus 2. So x equals to minus 10. Yes, that is the answer to question 8. X is minus 10. On to question 9. What we have is still based on the idea of lowest common base. So what we have here is actually 3 times the 9 here should be 3 square or raised power 1 plus x. That way I've been able to break it down into a lower base. Okay, that's what we mean by saying lowest common base, so that the base just rhymes all through. And then 27 is 3 raised to power 3 or raised to power minus x. So what I have here is 3 times 3 raised to power 2 times 1, 2, 2 times x, 2x. 3 here is the same thing as 3 raised to power 1 equals to 3 raised to power minus 3x. Product power law, 3 times minus x. That's going to give me minus 3x. So that this and this becomes 3, 1 plus 2 plus 2x equals to 3 minus 3x. The same base on both sides takes that out. So 1 plus 2 plus 2x equals to minus 3x. Of course, I could bring minus 3x here so that it becomes 3x. I have plus 2 here. 1 moves here minus 1, 2 moves here minus 2. 3x plus 2x, that's going to give me 5x equals to minus 3. So that x equals to minus 3 over 5, because 5 is going to the other side to divide. And there I have my answer, minus 3 over 5. Moving on to question 10, we were told to find x. In this case, we had 5 raised to power x plus 1 plus 5 raised to power x equals to 150. Equals to 150. So, when we have something like this, just like I said while I was answering question 3 and 4, we need to begin to think about having a quadratic equation in this instance. But that said, for me to have this means 5 raised to power x times 5 raised to power 1. That's what I have here, plus 5 raised to power x, and then 150 is 150. Okay. And then I'm beginning to think, okay, let 5 raised to power x equals to a. So that 5 raised to power x here is what? A. This is a times 5 plus a equals to 150. So that what I have, 5 times it, so that is 5a plus a equals to 150. So that this is 6a equals to 150. So that my a equals to 150 divided by 6. Therefore, my a is actually 25. So if a is 25, but recall that we said 5x equals to a. Substitute 25 for a, that means 5 raised to power x equals to 25. So that 5 raised to power x, you use your idea of lowest common base, and then you have 5 square. 5 take away 5, x equals to 2. Nothing special. It is just about you knowing when to use variables or letters of your own to replace certain quantities in the question. So moving on, question 11, that is 1980 question 34. So you can see in a single year you have 2 exponential equations, 1980 question 33, 1980 question 34. So what are we exactly saying is that there are certain topics that you cannot wish away. You expect them to come naturally. So the best you can do is to try and own the skills you need to be able to solve. In the case of exponential equation, majorly it's always about, if you have decimals, you try to change it to fraction, and then you introduce the idea of lowest common base. There are some exponential equation. Of course, you need to convert them to a quadratic equation and then solve. And then there are some some exponential equations. You just have to operate with your idea of having a generalized lowest common base, common to whatever you have to solve. So in this case, I was told to solve the system of equation. I was given two equations and I was told to solve the system of equation. I think that is pretty direct, looking more simultaneous. Okay, now dealing with this first equation here, this will mean 2 raised to power x plus y equals to 2 raised to power 5, and then 2 will take out to lowest common base, x plus y equals to 5. And then for this is 3 raised to power 3 y minus x, and then I have 27, which is 3 raised to power 3. This will strike out this, so what I have is 3y minus x equals to 3. So this is looking more or less simultaneous. This is my first equation, this is my second equation, so that what I have here is very simple. Let me make x the subject, making x the subject. This is equation 1, this is equation 2, making x the subject in equation 1. So that will be x. If y leaves, it becomes 5 minus y. Of course, I can then substitute 5 minus y for x in equation 2. So equation 2 is where I have 3y. My x is going to be 5 minus y. You can see I had to put a bracket there so that the minus have effect because it's a compound number. So 3y minus times 5 minus 5 minus times minus y plus y equals to 3. 3y plus y, that is 4y. Minus 5 moves here, 3 plus 5. So 4y equals to 8. Therefore, y equals to 8 over 4. And that means y equals to 2. That we have been able to calculate for my y. My y is 2. And trying to calculate for my x, I could use equation 1. If I use equation 1, x plus y equals to 5. So looking for my x, that would be x plus my y is 2 equals to 5. So that x equals to 5 minus 2, my x equals to 3. So in this case, y is 2 and then x is 3. That is what that question means by saying we should solve for the system of this equation. It means we should calculate our x and y. Moving on to question 12. If 3 raised to power 2y Okay, moving on to the next question, question 12. That is 1985, question 18. We have this here, and it's looking, probably we're going to have a quadratic equation here. Of course, I'm seeing 3 raised to power y, so I can use this to imitate this, so that this is like 3 raised to power y all square. Invariably, product power law, y times 2 will still give you 2y minus 6, 3 raised to power y. I could bring the 27 here so that it is minus 27 equals to 0. Okay, let 3 raised to power y be, let 3 raised to power y equals to b. Let me use b. So this is going to be b squared minus 6b, 27, okay, minus 27 equals to 0. So this is the quadratic equation I need to solve. So this times this gives me minus 27b squared. What are the factors? What are the factors? So what are the factors I need to make use of here? My factors, I'm looking for two terms that if I multiply them, I'm going to get minus 27b squared, and if I sum them, I'm going to get minus 6b, and I'm thinking that is minus 9b and plus 3b. I am owing 9b. If I have 3b and I pay, I'll still be owing 6b, so that I can then replace that b squared. This and this will replace 6b. Minus 9b plus 3b minus 27 equals to 0. So I then group b squared minus 9b plus 3b minus 27 equals to 0. So this out. So what is common to this and this? B minus 9. B, bring that out of the bracket. It needs to factorize that. What is common to this and this? 3. Then you have b minus 9 plus 3 times b plus 3b plus 3 times minus 9 plus times minus 3 times 9, 27. So what you have is b plus 3, and then you have b minus 9 all equals to 0. So b plus 3 equals to 0, or b minus 9 equals to 0. So what that means is that b equals to minus 3, or b, if minus 9 moves here, becomes 0 plus 9, that is 9. That is my two answers for b. But when I look at it, I have b. I cannot use a negative number here as my base here. So what I'm going to be going for, I'm going to be going for this. So using this, what I have is 3y raised to power y equals to b will mean equals to 9. So that means 3 raised to power y equals to 3 squared, and that means 3 out. So that means y equals to 2. Nothing more, nothing less. Y is equal to 2. We've been able to solve for y. So talking about question 13, this is what we have, and we were told to look for 3 raised to power x plus y. That is 1986 question 5. Of course, it is still based on the idea of lowest common base. So if you pick on this, you have 5 raised to power x plus 2y equals to 5. 5 is the same as 5 raised to power 1, so this out. So I have x plus 2y equals to 1, and then if I pick on this, that is 4 raised to power x plus 3y equals to 16 will mean 4 squared. 4 takes out 4. So I'll be left with x plus 3y equals to 2. This is looking like my equation 1. This is looking like my equation 2. I could use an elimination method there. So x plus 2y equals to 1. X plus 3y equals to 2. Subtract equation 1 from 2, in that the x looks the same already. So I could eliminate that. X minus x off. That's 0. 2y minus plus 3y. Minus times plus, that will give you minus 2y minus 3y, that will give you minus y. 1 minus 2, that will give you minus 1. So therefore, minus y equals to minus 1, y equals to 1. Now that I have my y as 1, I could substitute for y in equation 1, so that x plus 2, my y is 1, equals to 1, so that I have x plus 2 equals to 1. Therefore, x equals to 1 minus 2. My x equals to minus 1. But I think it just not end there. I've gotten my x in this regard. I have my y. I have my x to be minus 1. What I was told to look for is 3. I was told to look for 3 raised to power x plus y. So what is my x? 3 raised to power minus 1 plus my y is 1. Minus 1 plus 1, that's going to give you 0. So 1 is the answer for this question 13 when we combine both equations. So that ends question 13. Moving on to solve last 3 set of questions, question 14, 15, and 16, all JAMB pass questions. We have a question for question 14. It states, so what are the values of y which satisfy the equation of course, you have 9 raised to power y minus 4 into bracket 3 raised to power y plus 3 equals to 0. Just like earlier examples, solutions we've had, when you see things like this, you begin to think it's going to go the way of forming a quadratic equation from what is from this exponential equation. So regardless, this means 3 raised to power 2, and then I have y here minus 4 into bracket 3 raised to power y plus 3 equals to 0. For example, all that was written here is just meant to confuse you. This is the equation you want to solve. Just focus here. So telling you what are the values that satisfies it. When you solve your quadratic equation, of course you will get 2 values. So those will be the 2 values that will satisfy this equation. So what we have here, I could bring 3y here. So 3 raised to power y all square minus 4 3 raised to power y plus 3 equals 0. So having 3 raised to power y here, 3 raised to power y here, I could say let 3 raised to power y equals to a, so that this will be a square minus 4a plus 3 equals to 0. And this is what I need to solve. A squared times 3, that will give me 3a squared plus 3a squared. What will be the factors? The factors, I'm looking for 2 numbers, which if I multiply will give me this, if I sum will give me this. That is minus 3a and minus a. Minus a is the same as 1 minus 1a. Minus 3a minus 1a will give me minus 4a. Minus 3a times minus 1a. Minus 3 times minus 1, that's plus 3. A times a squared. So this goes. So therefore, I could have a squared minus 3a and minus a will replace 4a. Minus 3a minus a plus 3 equals to 0. So that what I have here is I then group a squared minus 3a minus a plus 3. Grouping this is what I'm going to have. A squared minus 3a. So a and 3a, that's going to give me a minus 3. And then I'm going to have minus here. Of course, this will be 1. Most common to this, and this is 1. So I'll be left with a minus 3. Reason being, minus a times a minus a. Minus 1 times minus 3 plus 3 equals to 0. So what I have is a minus 1, a minus 3 equals to 0. So what I have is a minus 1 equals to 0, or a minus 3 equals to 0. Therefore, a equals to, if minus 1 moves there, it becomes plus 1, or a equals to 3. So working on this, but my a is 3 raised to power y. So 3 raised to power y equals to 1, or 3 raised to power y equals to 3. For me to have 3 here is same as 1. So this off. So my y is 1. Now for me to have a 1 here, that is that must have been 3 raised to power 0. 3 raised to power 0 will give me 1. So this. So y equals to 0. So looking at this, the 2 values that satisfies this equation is going to be 0 and 1. Straight and direct. 0 and 1. Moving on to question 15. This is what we have, and we must just work with the idea of lowest common base. Having 9 here means 3 raised to power 2, or raised to power 2x minus 1 divided by 27, that's 3 raised to power 3, or raised to power x plus 1 equals to 1. But mind you, since I'm having 3 here, I'm having 3 here. If I'm seeing 1 here, 1 there means 3 raised to power 0, because anything raised to power 0 is 1. Then I can combine this. So this means 2 times 2x, 4x, 2 times minus 1 minus 2. And then here I have 3 raised to power 3x, 3 times 1, 3 equals to 3 raised to power 0. So I need to take this and this together. So that's 3 raised to power 4x minus 2. The minus, of course, this is not a single exponent. It's a combined exponent. It's a compound exponent. So I have to put a bracket at 3x plus 3 equals to 3 raised to the power 0. So in this regard, 3, ordinarily we take out 3, so that I have 4x minus 2 minus times 3x minus 3x minus times plus 3, that's minus 3, equals to 0. So 4x minus 3x, that's x. Minus 2 moves to the other side, that's 2. Minus 3 moves, that's 3. So x equals to 5. I was told to look for the value of x. That is 2003, question 2. And last but not the least, question 16. We were told to solve for y in this equation. That is 1993, question 4. What does the equation look like? 16, 10 raised to the power y times 5 raised to the power 2y minus 2 times 4 raised to the power y minus 1. So what we basically have here, is I'm having 10 raised to the power y, I'm having 5, I'm having 4. This is not looking like something I can really use lowest common base for, but I have to still find a way to work things out. All equals to 1. Okay, so this is what I'm going to do. Recall that, let's say we have 8 raised to the power 2. 8 raised to the power 2 is 64. Similarly, I could break this down to 2 times 4, all raised to the power 2. That will be 2 square times 4 square. 2 square is 4. 4 square is 16. 16 times 4 is 64. So what I have here is 2. I could break this down to 2 times 5, all raised to the power y. So what I have here, I could break this down. That's 2 times 5, all raised to the power y, times, okay, for me to have a minus 2 here, that means this must be 5 raised to the power 2y, 5 raised to the power 2. It was because it was division, that was why there was a subtraction here. And then this is 4 raised to the power y divided by 4 raised to the power 1, which is same as 4. That's what that looks like, all equals to 1. So this will mean 2 raised to the power y times 5 raised to the power y times 5 raised to the power 2y times 4 raised to the power 4 here should mean 2 raised to the power 2y, 5 square, 2 square, all equals to 1. So this is 2, this is 2. This all looks like my numerator now. This is 2, this is 2. So that's looking like 2 raised to the power 3y. And this is looking like times 5 raised to the power 3y divided by 5 square is 25. 2 square is 4, equals to 1. So 2 raised to the power 3y times 5 raised to the power 3y equals 25 times 4, 100. 100 we move here, and that is what I have for now. So looking at this, since I have, like for this example I used here, I have 8 square, I could split that down into 2 times 4 and sharing the same power. This is 3y, this is 3y, the powers of the exponents looks the same. So this could mean 2 times 5 all raised to the power 3y equals to 100. So that what that means is 2 times 5 now is going to mean 10. 10 raised to the power 3y equals to 100 means 10 square. So 10 takes out 10. So 3y equals to 2, and therefore y equals to 2 over 3. I was told to solve for y. So my y in this regard is 2 over 3. Nothing all too special. And with that, we've come to the end of exponential equation. If you have any exponential equation as far as your UTME exam is concerned and you're finding it difficult to solve them, do not hesitate. You can put that in the comments on this lecture video. You can reach out to us via website, visit 300plusacademy.com. There is a WhatsApp group link on the page, WhatsApp group on the page. Link up with us, and of course, DM any of the admin on our WhatsApp group, and we will gladly attend to your question. So don't also forget, subscribe to this channel, turn on the notification bell so that at each time that we upload lecture content that relates to your exam, you're being notified and you can quickly get into the fray of things. From us at 300plus.com, it's bye for now.